Hello and welcome to my video presentation on circuit breaker selectivity. My name is Martin Lavachka, and in this video I'm going to explain what circuit breaker selectivity is, its benefits, the conditions to achieve full circuit breaker selectivity, and the selectivity methods. Before moving on to the next slide, I recommend that you watch the short circuit and circuit breaker basics videos that I made to understand all the information mentioned in this video in context. I'll leave links to the videos in the description. Now let's get started. What is circuit breaker selectivity? We define it as the coordination of a circuit breaker to prevent tripping of any circuit breaker except the one immediately upstream of a fault position. It is required for installations supplying critical loads where overload or short circuit fault in one circuit should not cause disconnection of other circuits. What are the benefits of selectivity? The first benefit is safety, since it provides continuity of service in critical facilities such as hospitals or tall buildings. The second benefit is reduced downtime and increased productivity, as it makes it easier to locate the fault. The trip device is closer to failure. All you have to do is inspect the circuit related to the next device or load. The third benefit is customer satisfaction, as it provides comfort in hotels or supermarkets by reducing the magnitude of breakdowns in the building. The fourth benefit is the reduction of financial losses in the industry or data centers. How to achieve selectivity? Coordination of circuit breakers is done by selecting the correct frame, the correct trip unit, and the correct configuration. To achieve total selectivity between two circuit breakers, two conditions must be met. The first condition is that the upstream circuit breaker has a normal rating for frame and trip unit 2.5 times that of the downstream circuit breaker. The second condition is that the maximum short circuit current and an installation point is below the selectivity limit of the upstream circuit breaker. For high short circuit currents, selectivity between category B circuit breakers can be ensured by disabling instantaneous tripping and setting the short time delay. The selectivity principle is based on the comparison of the upstream and downstream breaker tripping curves. The selectivity between two circuit breakers can be total, which is up to the breaking capacity of the downstream circuit breaker, or partial, which is up to a specified value according to circuit breaker characteristics. There are three selectivity methods. The first selectivity method is current-based and is implemented by setting successive tripping thresholds at steep levels from the downstream circuits towards the source. The second selectivity method is time-based, which is implemented by adjusting the time delay tripping units such that downstream relays have the shortest operating times with progressively longer delays toward the source. As is shown in this two-level arrangement, upstream circuit breaker A is delayed sufficiently to ensure total selectivity with circuit breaker B. Remember that only selectivity category B circuit breakers are designed for time-based selectivity. The selectivity limit will be the upstream short time withstand value. What is that category B circuit breaker? To fully understand the time-based selectivity method, let's have a look at what that means. The IEC 60947-2 standard defines two types of circuit breakers defined by their selectivity category. The first, selectivity category B. This is usually the case with air circuit breakers and some heavy-duty MCCBs. These circuit breakers provide selectivity by having a short time withstand current rating and an associated short time delay. The short time delay is possible to implement in situations where the fault current level is lower than the short time withstand current rating. ICW is the maximum current that the B category circuit breaker can withstand, thermally and electrodynamically, without sustaining damage over a period of time. The second selectivity category is A category. This is the case with all other breakers, MCCBs or MCBs. These breakers have no deliberate delay in the operation of instantaneous short-circuit magnetic tripping device. Under certain short-circuit conditions, the breakers can provide selectivity, but the manufacturer will not provide ICW value. Let's look at the third selectivity method, which is based on a combination of the current-based method and time-based method. Delay added to a current level scheme can improve overall selectivity performance. As can be seen from the tripping curve, the upstream circuit breaker has two magnetic tripping thresholds. The first threshold is a delay magnetic trip or short delay electronic trip, and the second threshold is an instantaneous magnetic trip. Total selectivity can only be guaranteed if the short circuit breaking current of the downstream circuit breaker is less than the instantaneous magnetic trip of the upstream circuit breaker. We come to the end of this presentation. You now know circuit breaker selectivity. Thanks so much for looking. Stay tuned for the next video where I'll explain selectivity enhanced by cascading.